Hi class, these are your notes for 5.1 that's going to cover apportionment. Now in the beginning of these notes I'm asking you to take the time to read your textbook, and for this space I'm asking you to read the first 2 pages and watch that 3/5 compromise video that I posted that explains how it came to be that slaves were counted to be able to vote. The book does a really good job of explaining the history behind apportionment and how our government is founded on slavery, and it's really important we know that history to move forward with our nation. And I really just take the time to read over it, and this space is just left blank for you to take any notes that you need to. The book does a good enough job. I don't need to just regurgitate everything the book says. So again, take the time. All right. So I'm going to focus on the math in these videos. And apportionment is the problem of dividing up a fixed number of people or items among groups of different sizes. For example, we use apportionment to determine the number of representatives for each state in the U.S. of House of Representatives. We could also use apportionment in other problems. So I list here, to divide school buses among districts. It could also be to figure out how many employees work for each shift. And for the example we are going to do throughout these notes is like to determine how many full-time math instructors go to each campus. So there's different ways you can use this. Now, in general, the rules of apportionment, so this is just in general, they're going to seem like very similar lists because they are. The people and items can be divided into just whole numbers, which makes sense because we can't have like a 0.5 of a person. The second rule is we must use all, no more, no less, of the people or the items being divided. The third is each group must get at least one of the people or the items being divided. And the fourth rule is the number of people or items assigned to each group should be approximately, so I'm just going to notate it like that so I have enough room, approximately proportional to the size of the group. So it's pretty rare we can get exact, so you just want to get as close as you can. Now, when we are discussing House of Representatives and the history, now for today, the rules are we can only have whole representatives, which makes sense, right? We can't have 3.4 representatives. Now, this is the case now, and it wasn't always the case, but now we have 435 representatives available for the 50 states that we have. Every state has to get one. And then the fourth one is the number of representatives should be approximately proportional to the state population. And so what we're going to discuss in these videos are all these different methods and how we came about to figure out how many representatives each state gets. And so your book will talk about that history piece. And again, I'm going to really, really ask you to read it. In the videos, we're going to look into these 4 different methods of solving the apportionment problem. And they are the Hamilton's method, Jefferson's method, Webster's method, and current today method is the Huntington-Hill method. And so what you'll do is in my open math, you will be asked to use these methods to find the apportionment for certain things. And it might be House of Representatives for, a made-up state, or it might be, employee shifts or whatever it could be. Now for us, we are going to focus on, each video will be a different method, and we're going to use the same example for each video, but just using different methods. And so the Hamilton's method, this method was used between 1852 to 1910. And I would never ask you that on a test or anything. It's just, I think it's cool to know. So Hamilton's method, here are the steps. And what I'm going to do is I'm going to go between reading the steps and going to the example. So then it just hopefully makes more sense, because sometimes when you read too many steps, it's overwhelming. So the first step says compute the divisor. D is what we call it. And that's the total population divided by number of seats. And I'm using that word seats because this is in relation to a House of Representatives. Now, if I go to my example 1, it says PCC has 4 campuses and 45 full-time math instructors. The number of students at each campus is given in terms of full-time equivalency, so FTE. How can we divide up the math instructors fairly? And what I mean by FTE is like it's determined on how many students are going to that campus full-time. So it's based on how many credits students are taking. And this data is given by this link. So what I'm going to do is the first step, it says I need to take the population and divide it by how many available things there are. And so for this case, I need to add all of these values up to get my total. And I'm going to go ahead and go to Google Sheets, which I already have in here. And just so you look down here, see how I put equals and then I added all of the campus's FTE together? So if you're relying on Google Sheets, just to remind you, if you want it to do any operation, adding, multiplying, dividing, you have to start the equation with an equal sign. And then it's letting it know. And then you put in whatever you're trying to find. So my total is 23,231. 23,231. And so that first step says, find your divisor D. So I'm going to do my total population, and I'm dividing it by how many full-time math instructors there are available. And when I do that division, so again, I'm going to go back to Google Sheets. I did it here already. See how I put in, let me just do it again actually, just to make sure it sits with you, equals. I'm going to just select that cell, divide it by 45. I really like that option because it puts in the exact value, but you can be my guess and type in the value. It does not matter. So I get 516.24444. You can round. For me, so I don't have to, it's going to be 516.24 repeating. All right, now the second step says find the quota. So now I want to take the state population and divide it by your divisor. And it says record answers to several decimal places. Just you'll see why that's important in a second. And so for us, what we're going to do is I am going to take each campus and I'm going to divide it by our divisor. So I'm putting it up here so it makes sense. I'm dividing each campus's FTE by its divisor. And I'm going to totally rely on you all that you feel okay with using Google Sheets or your handheld calculator so I don't waste your time. And so when I do, and I'm going to just show it for the first step because I think I'll run out of space, but just so you know what I'm doing. And I'm going to use approximately because I am going to have to round. I get about 17.18, and I'm going to keep going, 3, 7. And you can keep writing as much as you'd like, but just don't round to the tenths because that might be misleading. All right, so each step, I'm going to do 4,841. I'm going to divide it by the divisor, and I end up getting 9.3773. I'm going to take 6,797. I'm going to divide that by the divisor, which is 516.24 repeating, and I get 13.16624. Take that last one, and I'm going to get 5.2727. All right, so that's my second step. And let me actually, just so we're on the same page, I'm just going to show you. If I wanted to do this, I would do equals again in Google Sheets. And I'm just going to do Sylvania really quick because I feel like I should show you how to use this. And I'm going to divide. I'm just going to select that cell. So then I don't even have round off errors, okay? So just make sure, dividing by the whole value is way better than dividing by a rounded thing. Because what you do is, if that happens, you just keep rounding and rounding and rounding throughout the problem. And then by the final answer, it's off. All right, so we can only have whole representatives. So I can't go to Sylvania and say, okay, you get 17.18 full-time math instructors. So the third is find the initial apportionment by cutting off the decimal parts. Add the whole numbers. And what I mean by that is, and don't lose track of them. So what I'm going to do is, I'm not going to erase them because that would be confusing. So I'm just getting rid of these decimals. And so then my initial would be 17, 9, 13, 5. The next thing says, and then add them. Well, if I do 17 plus 9 plus 13 plus 5, I actually get 44. And that's where you get stuck because, wait a minute, we have 45 math instructors. So that's when we have to start messing around with this. And so the fourth step says, if step 3 is less than the total number, which it is for us, we need to distribute the surplus seats, 1 per state, starting with the largest leftover fractional part, and then we proceed. So this method is actually the easiest method because you don't have to do more math behind it. You'll see when we go through other methods. So what that last step means is, let's find who has the biggest decimal. And it looks like this is our biggest decimal or our largest fractional piece. So what that means is this will stay 17, but they will get, because I only have 1 extra seat. Okay, so if I had numerous extra seats, I would just keep going down the list, but I only have 1. And so that one goes to 10. That will stay at 13. That will stay at 5. And then what do you know, when I add them up, we get 45. And so that is how you do Hamilton's method. Let's just discuss a little bit more before we go on to the next method. I wanted you to see here, I'm going to click here. So there were some problems with Hamilton's method. And so in 1792, I found this awesome, let me get out of here, all this stuff. I don't know if it will open. So let's see. We're going to keep going with this. I don't think it will because, oh wait, maybe it will. Let's see. Okay, cool. So this is a cool Excel sheet. And these were in 1790, there was a census given, right? So we could figure out our population. And you'll see here, it's so awesome. Like, let's look at Virginia. We got the total population. And at this time, there's only 120 seats available. So right now we have 435 seats available because our population's bigger. We took the population, we divide it by the seats, and we get all of these decimals. Remember, we always just cut off the decimal piece, so that's why we get 20, 15, 14, so forth. They're keeping track of that fractional piece, which is awesome. And then what happens is, when I round down all of those states, I'm only left with 111. So that means we have 9 seats to give away. And so what we did is we went in order. So we went to, like, the biggest fractional piece gets a state. Then the second largest fractional piece or decimal gets a seat, and so forth. So you just go down 9 states. Well, what happens here is there was this rule that was like an understood rule in Congress that we wanted 1 representative per 30,000 people, okay, minimum. And what you'll see here is in this last column that when I gave out all these seats based on Hamilton's method, that's not happening. And so that was a big problem from George Washington. And so that's why he was like, I'm going to veto this, and we're going to have to come up with another method. I just thought that was really cool. Going back to the notes, there are other reasons why certain methods got we got rid of certain methods. So Hamilton's method led to several paradoxes. I also want to say here, and other methods. It wasn't just Hamilton's method that led to these paradoxes, and other methods. And again, your book does a great job, and I really want you to take the time to actually read through and see how these paradoxes happened. And then I'm going to just reiterate, I want you to read, and then I'm going to go through and do the math with you. Now, the next video will cover Jefferson's method. So I'm going to stop this guy, read your book, and I'll see you in the next video.